Well, hello everybody. What I need to do with you today is really I need to cover the last derivatives that I'm going to cover with you. Last time we covered the derivatives of e to the u, and we also covered the derivative of a to the u. Remember, the only difference is one's got a base of e, the other has a base of any number greater than 0. We can't allow negatives to show up. What I need to cover with you today then is the logarithmic derivatives. I need to cover with you the derivative of the natural log of u, and then I need to cover with you the derivatives of the logarithmic functions, those that kind of look like this. So you should have in front of you your class notes for section 4-4. It'll be the one that says the derivative of y equal natural log of u and y equal log to the base a of u. Now, as we get going, before I start the lesson, I want to kind of review a couple of things with you. Remember, the natural log has a base of e. So if you look on my screen there, I've got the natural log of e to the 6th. Guys, there's really a base of e hiding right there. If I write this as an exponential, I would have e to the x equal e to the 6th. Since my bases are the same, I can get rid of those. So in this case, I know x is just going to be 6. What I'm trying to get in your head right now is to get rid of that natural log and write it as an exponential. There's that base of e right there. So natural log of some number is 4. Well, it's got a base of 4. That means that e to the 4th is x. And then we can run that through our calculator, that 2.71 number to the 4th. One last one, the natural log of some number is 2.5. Well, to get that number, I would take e to the 2.5 equal x, and I would run that number through your calculator. I need to slide that in you real fast because that's what I'm going to be doing here in a little bit. So if you would, look at your very first example. It says y equal the natural log of x. I'd like to, of course, find the derivative of the natural log of x. So here's how I'm going to attack it. I've got y equal the natural log of x. I'm going to write that as something that I recognize. So I'm going to get rid of that natural log. So there's that e hiding right there. So I'm going to write this as e to the y equal x. The reason I did that, last class we talked about how to find the derivative of the e function. Well, to do that, it's the e function that you see times the derivative of the exponent. So now let's go find the derivative of each side. So the derivative of e to the y is going to be e to the y dy dx equal the derivative of x with respect to x is going to be 1. Now let's solve this for dy dx. Dy dx is going to be 1 over e to the y. But now, just like I did last class, watch what I do here. I need another name for e to the y. Well, if you look back up right there, we said that e to the y is equal to x. So the derivative of the natural log of x is really 1 over x. So here's a piece of information we're going to add to your note card here pretty quick. The derivative of the natural log of x is 1 over x. So there's where I am so far. Now, if you would, come over to your next one. Oh, I threw this in. This lesson's really kind of easy, but it can sneak up on you as we start rewriting the natural log functions. So here goes my next one. I've got y equal the natural log of 5x. Well, y equal natural log of 5x. Remember, there's that e hiding right there, so let's write it as an exponential next. So I've got e to the y equal 5x. Now let's go find the derivative of each side. Well, the derivative of e to the y is going to be e to the y times the derivative of the exponent, and the derivative of 5x is going to be 5. Let's solve that thing for dy dx. So I've got dy dx is 5 over e to the y. Now I'm going to do this to you again. Another name for e to the y is 5x. So my derivative now becomes 5 over 5x, which simplifies to be, in this case, 1 over x. Now, the reason I'm showing you these steps right now, guys, believe it or not, there's a shortcut to go from there to there. We just got to find it. I'm going to point it out, and it's going to become obvious as we go. If I've got you lost on there, just keep hanging on. Here goes my number 3. I've got y equal the natural log of x cubed. Once again, I'm going to rewrite it as an exponential. So I've got e to the y equal x cubed. Let's go get that derivative. Well, the derivative of e to the y dy dx equal 3x squared. Let's solve that for dy dx. So I've got dy dx is 3x squared over e to the y. Well, I need another name for e to the y, so let's look right back to there. Looks like another name for e to the y is going to be x cubed. So now my derivative becomes 3x squared over x cubed. Once again, there is a way to go from there to there. Kind of see if you can start figuring it out. Now, I'm not 100% done with this problem. I'm going to simplify this. I can take out an x squared from the numerator and x squared from the denominator. So my derivative simplified to be 3 over x. So start in your mind, try to start forming a way to go from there to there. I've got a couple more, and I think it'll become pretty obvious here pretty quick. We're going to look at y equal the natural log of 3x plus 2. Once again, let's write it as an exponential. So I'm going to have e to the y equal 3x plus 2. Let's take the derivative of each side. So I've got e to the y dy dx equal the derivative of 3x plus 2, which is 3. Let's solve this for dy dx. So I've got dy dx is 3 over e to the y. And then you know where I'm going to go again. Another name for e to the y is what was originally with the natural log, in this case 3x plus 2. So my ending derivative in this case is 3 over 3x plus 2. So guys, start once again. There's a shortcut to go from there to there. I'll hit this one last one. We'll talk about the shortcut if you hadn't got it figured out, and I'll make sure you're pretty good at it. So here's my last one that I'm going to do the longer way. I've got y equal the natural log of 2x squared. Once again, let's write it as e to the y equal 2x squared. The derivative of e to the y happens to be dy dx with the e to the y equal the derivative of 2x squared, which is 4x. We're going to solve this for dy dx, so I've got dy dx is 4x over e to the y. But you know where I'm going now. dy dx is really 4x over another name for e to the y, which is 2x squared. We're not 100% done yet, but there's a shortcut to go from there to there. Now, let me simplify this. 4 over 2 happens to be 2. Looks like your x's cancel out, so 2 over x. There's a reason things reduce, which we'll talk about as we go. But I'm hoping at this point, guys, you've got the shortcut figured out. Since it's a video, in case you don't, let's talk about the derivative of the natural log of u. If you look back at the other examples, it's going to be 1 over our u, whatever our quantity is, 1 over our u times the derivative of our u. Another way to write this is, it's the derivative of your u function over your quantity. So at some point, get that written down on your note card. You'll want to say the derivative of the natural log of u is 1 over u du, or the derivative of u over u. After you see a couple of them, you'll see why it's so easy. So, here goes your next slide. Now it's a shortcut time. We're not going to write all of these as an exponential and then reduce it and do all those extra steps. We're going to go straight to the derivative. So dy dx is going to be the derivative of what you see over what you see. The derivative of what you see over what you see. So I've got 7 over 7x. Let's simplify that and get 1 over x. You'll notice, guys, whenever you're finding the derivative of a constant x, it's always going to be 1 over x. There's a reason for that, which I'll explain to you when I see you in person. Here goes my number 7. The derivative of the natural log of 2x plus 7, so I've got dy dx, is the derivative of what you see over what you see. 2 over 2x plus 7, we're done. You can't cross those 2's out. There's no monomials in common, so you're done. Here goes my number 8. dy dx is going to be the derivative of what you see over what you see. Look at each term and see if they have something in common, and in this case they don't, so you're done. You can't simplify that anymore. Another easy one, of course I'm going to make them harder, so don't jump out of the video at this point. So dy dx is going to be the derivative of what you see, 4x minus 5, over what you see, 2x squared minus 5x plus 12. And then we're done. Okay. So there's the first handful of them. I'm going to keep using that rule. I'm going to keep using that derivative. We're just going to apply the other rules of logarithms. So I'll slow down just a little bit here. So come over and look at your number 10. I've got the natural log of 1 minus x quantity to the 3/2. When you're dealing with the derivative of a natural log, you do not want to see powers. You want to get rid of them first. So I'm going to rewrite this using our rules of logarithms. I'm going to bring that 3/2 down front. So this is really 3/2 times the natural log of 1 minus x. 3/2 times the natural log of 1 minus x. Now to get this derivative, I don't need the product rule because this is just a constant. So I got 3/2 times, now focus on the derivative of the natural log of 1 minus x. It's going to be the derivative of what you see, which is -1, over what you see. So guys, the 3/2 was my exponent. The -1 over 1 minus x was the derivative of the natural log function. Ending answer, -3 over 2 times 1 minus x. If you'd like to distribute that 2, you sure can. One's not better than the other. Okay? But the moral of that story, if you have an exponent, get rid of it first. On one of my slides coming up, I have an example where you don't get rid of it. It's ugly. Here goes my number 11. This says the natural log of the cube root of 2x minus 8. Well, we're going to think of this as the natural log of 2x minus 8 to the 1/3 power. Let's rewrite this as y equal 1/3 natural log of 2x minus 8. Now we're ready to go get this. The derivative of this will be the 1/3, that original power, so the 1/3 times the derivative of what you see over what you see. Now we're not done yet, of course. Let's try to simplify this. This becomes 2 over. If I distribute this 3 inside here to show you something, I've got 6x minus 24. But do you see a number that goes into all of them? And if you look at each term, looks like a 2 goes into all of them. So here's my final answer. This derivative is going to be 1 over 3x minus 12, or 1 over 3 times x minus 4. Same answer. You can leave it either which way you like. Then it looks like I've got one more before I change pace just a little bit. So on my number 12, I've got y equal the natural log of x cubed plus 2x to the 1/3 power. Let's rewrite that as y equal 1/3 the natural log of x squared plus 2x. Now this derivative then is going to be, I've got the 1/3 out front times the derivative of what you see. So it looks like a, oops, that should have been an x cubed in there. So the derivative of what I see is 3x squared plus 2 over what you see, x cubed plus 2x. Final answer, a couple of ways to leave it. I've got 3x squared plus 2 over, I can distribute that 3 or leave it out. You pick it. So there's our derivative. The main focus there, guys, is if there's an exponent, get rid of it first. Get rid of it first. Now I'm going to switch gears on you just a little bit, and then I'll finish up my natural logs. And of course my title is, you know we cannot keep it that easy. Notice that the product rule keeps showing up. So notice this, guys. I've got an x cubed times the natural log of 2x. That cries out for the product rule. So here goes the product rule. I've got f prime of x is going to be the derivative of the first times the second plus the first times the derivative of the second. Well, the derivative of the natural log of 2x is going to be 2 over 2x. Well, let's simplify this now. I've got f prime of x is 3x squared times the natural log of 2x plus, if I simplify this, the 2's cancel out. X cubed over x looks like x squared. Remember, whenever we use the product rule, we usually have to follow it up with factoring. So let's factor out anything in common. So in this case, I can factor out a x squared which is going to leave me a 3 times the natural log of 2x plus 1. And then there's my answer. So the product rule, of course, doesn't go away. Here's another one just like it. It's another product rule because I have something with the variable in the front followed by some other expression. So here goes. I've got the derivative of the first, 4x, times the second. Don't get caught up when there's absolute values and when there's not absolute values. Our book likes to use absolute values every now and then to show you that you can't take the absolute value, you can't take the natural log of a negative number. So I got the derivative of the first times the second plus the first, 2x squared, times 6 over 6x. Or, if you recognize it, 1 over x. Let me simplify this for you. So I've got 4x times the natural log of 6x plus, looks like the 6's cancel out. So it looks like I've got 2x squared over x, so it looks like that becomes 2x. Factor out whatever they have in common, which in this case looks like a 2 and an x, which leaves me, looks like a 2 natural log of 6x plus 1. Okay. So guys, that's going to pretty much finish up my natural log functions. I'd like to jump into the logarithmic functions now. In class, I was going to hit a couple more, but I'd like to jump into the log so my video doesn't get much over 30 minutes. So I'm going to bypass your number 15 and number 16, the exact same thing that we've been doing. So let me switch gears now to talk to you about the natural log, the logarithmic functions. So if you would, pop over to your number 17 that says y equal log base 3 of x. Log base 3 of x. Once again, but I'm not going to do 20 of them this time. I'm going to do a couple of them to show you where it comes from, and then there's a shortcut once again. And then you'll have another formula that you can put on your note card. So here's where I'm going to start first. I've got y equal log to the base 3 of x. We know nothing about the log function, the LOG function. So I'm going to rewrite it as something that I do know something about now. I'm going to write this as an exponential. I'm going to write this as 3 to the y equal x. Now the reason I'm going to do that, last class we looked at how to find the derivative of a to the u. Remember that derivative from last class is a to the u, whatever your expression is, times the natural log of the base times the derivative of your exponent. So now let me apply that to 3 to the y. The derivative of 3 to the y is going to be 3 to the y times the natural log of 3 times the derivative of the exponent, which is dy dx, and the derivative of the x is 1. Let's solve this for dy dx. So it looks like dy dx is really 1 over 3 to the y times the natural log of 3. But we're not done yet, you know that. See if this game sounds familiar? I need another name for 3 to the y. Well, if I look right there, notice another name for 3 to the y was x. So here's my derivative. My derivative is going to be 1 over 3 to the y happens to be x. And then I also have the natural log of 3. So the derivative of log to the base 3 of x is 1 over x natural log of 3. Once again, there's a shortcut to go from there to there. We just got to kind of start figuring it out. It may not show up yet, but I really think by the time I do my couple of others, you'll kind of get a hint. And if not, I will give you the rule. So here goes my next one. Y equal log to the base 5 of 3x plus 1. I'm going to write it as an exponential first. So 5 to the y equal 3x plus 1. Let's take the derivative of both sides. So the derivative of a to the u is going to be 5 to the y times the natural log of 5 times the derivative of the exponent, which is dy dx. And the derivative of 3x plus 1 is 3. Let's solve it for dy dx. So I've got 3 over 5y natural log of 5, which is equal to 3 over another name for 5 to the y, or u from earlier, that 3x plus 1. So another name for 5 to the y is 3x plus 1 times the natural log of 5. I'll say it once more. There's a shortcut from there to there. So start trying to piece it together. Look at a 3x plus 1 and a 3x plus 1. See if you can figure out where this 3 came from. And then see if you can figure out where that natural log of 5 came from. I'm going to derive one more to kind of show you the official rule. I'll give you another rule for your note card, and then I'll do 3 or 4 examples with you, then I'll be done with my video. So here goes the next one. Y equal log to the base a of x. So notice on this one, guys, I took away all the numbers. Steps are going to be the same. I'm going to go a to the y equal x. And it looks like on your guys' sheet, I changed this log to the base a of x. It looks like I changed that to a u. So let me quickly change this to a u so I'm consistent with your guys' worksheet. So now, the derivative of a to the y is a to the y times the natural log of a times dy dx. And the derivative of u is the derivative of u. We could write that as derivative of u du over dx, but I'm going to leave it like that. You'll see why. Let's solve this thing for dy dx then. And then listen as I say it to what I'm writing. I've got the derivative of u over another name for a to the y is u. So far, guys, I've got the derivative of u over u times the natural log of a. The derivative of u over u should sound familiar. It's just like the natural log. The only difference is I'm adding in the natural log of a. So, in terms of a formula for you, here's our formula. It looks really complicated, but it just says this. The derivative of log to the base a of u is, I would come right over here. I would write it as the derivative of u over u natural log of a. That's the cleanest way to write it. So I would put that in that formula sheet right under number 18. I would also put that over to your note card right away. I'll do 3 or 4 where I show you how easy it is to use it. I'll toss in the product rule, and then we'll be done with it. So pause the video if you need to write that down or backtrack it. But here goes. I'd like to find the derivative of log to the base 5 of x. Think what your rule says. It says it's the derivative of your u over your u times the natural log of the base. So f prime of x is going to be the derivative of the x, which is 1, over the x, times the natural log of your base. All done. When I move to my next one, this derivative is going to be the derivative of what you see. Here's your u part. The derivative of what you see over what you see times the natural log of the base. Now in this case, this simplifies. Your 4's cancel out. So once again, I could get x natural log of 5. The reason this is the same answer as what we had, I could, if we wanted, we could split this up. Log to the base 5 of 4 plus log to the base 5 of x, one of our rules of exponents. This is some number whose derivative is 0. This is just what we found. So that's why the answers are the same. Okay. 2 more easy ones for you. Here goes your number 22. Looks like this derivative is going to be the derivative of what you see, 6x plus 4, over what you see, the quantity, 3x squared plus 4x, times the natural log of the base, which happens to be natural log of 2. Unless something goes into 6, 4, 3, and 4, you're done. So in this case, we're done. One more easy one. Looks like my derivative is going to be the derivative of what I see over what I see, 3x squared plus 2x minus 3, times the natural log of the base. So in this case, guys, notice there's no base written down. But when we're dealing with just a regular logarithmic function, that base is 10. So then we got it. Now let me hit number 24 or number 25, because of course that involves the product rule, and then I'll have this video whipped. So let me hit number 24. I've got e to the 3x times the log to the base 2 of 3x minus 1. Well, looks like my derivative is going to be the derivative of the first. So it's that e function that we did last class. So it's going to be what you see times the derivative of the exponent. So I got the derivative of the first times the second, which is log to the base 2 of 3x minus 1, plus the first times the derivative of this log function, which is the derivative of what you see over what you see, natural log of the base. Now that looks really, really ugly. The only thing that we're going to do to try to clean this up is factor out whatever they have in common. So it looks like they have a 3 in common there and there. So I'm going to factor out a 3 and an e to the 3x. Out of your first term is going to be log to the base 2 of 3x minus 1. Out of your second term, I've taken that 3 away, I've taken that away, I'm going to have the fraction 1 over 3x minus 1 natural log of 2. Normally we wouldn't leave a fraction inside there, but in this case we're going to. So guys, that's the last section. Those are the last derivatives that I will teach you this year. We apply rest of the year, and then we start going backwards on those once you think you're really, really good with them. Now, the assignment isn't listed on your worksheet. The assignment is 1 through 39, the odds. This is out of the book. But just like last time, I have the book copied on to the Canvas account, or you can get through the back door. We're going to go 1 through 39, the odds. You're going to skip number 15, 17, and 23. But you're going to add in number 58 and 63. So there's the assignment out of the book. There's only 2 sections there. You'll find that. So good luck with it, guys. What's your notation? Kind of get good with your note card. If you don't have those formulas written on your note card, get those written down. Good luck. Come in if you need any help.